Hello everyone. Now in this video I am discussing with you about chapter number 9, that is algebra. What is algebra? It is a separate branch of mathematics. Yes, just we are studying like geometry, arithmetic. It is also a branch of mathematics. Here we are discussing about the variables and numbers. Yes, till now you are studying only about the numbers. But how do we add, subtract, multiply, divide and do the mathematical operation and other things between the variables and constant, and what is a constant, variable and so many terms we are discussing in this chapter. Now let's start. Just you want to make u by using the matrix. How many matrix you need for making one u? This is u. You want to make this u. So you know variable 1, 2, 3. How many matrix you need? 3. For making one u, you need 3 matrix. Okay? So total matrix is equals to 3. If you want to make 2u, in that situation, how much matrix you need? 3 and 3, 6. So, for 2 u's, you need 3 matrix and total matrix are 6. Because for each u, you need 3. So, total matrix is 6. Now, if you want to make 3 u's, in that situation, 3 this one, then next 3, then next 3 you need. Yes? How many matrix you need here? 3 matrix. For 3 u's, you need 9 matrix. Okay? And just many u's you can make, but how much total matrix you need? How to determine this? By counting in this way? No. See here, what is this? You can see. If you need 1, you are writing 1. If you need to make 2 u's, you are writing 2. If you want to make 3 u's, you are writing 3 here. Okay? But the matrix which is needed for 1 u, that is fixed. 3. Yes, that is fixed. So this place is, in each term, this place term is fixed. What is this? Which nature is this? Fixed nature. And you can see, as per our situation, we are changing this place values. So it is changeable. We are changing it, so it is changeable. Okay? So the number, the term which is fixed in nature is known as constant. And which is changeable in nature is known as variable. You can read as variable. Vari means different, changeable in nature. So variable means changeable. Now let's see here. You are needed 3 matrix for making 1 u, and so infinity you can find it just like you want to make n u's. How many u's you want to make? N u's. Infinity many u's you make. So what is the total matrix you are needed here? That is 3n. Why 3n? Because this 3 is fixed here and this n is variable. Which is variable, we are using the symbols and alphabets for these variables. Yes, constant is a fixed numeric value, and variable for representing the variable, we are using some specific symbols or alphabets. Now in this algebra, we have so many basic terms. So first basic term is constant and second is variable. Let's see the meaning of these terms. Constant, a fixed numeric value. A fixed numeric value is known as constant. So we can see each and every kind of numbers are constant. Here in algebra, just 0, 2 upon 3, minus 5, 1.25, etc. So many numbers are here and all the numbers have the fixed numeric value. So the number which have the fixed numeric value are known as constant. Variable. Variable means changeable in nature, means not have any fixed value. See here the meaning. A symbol which takes various numeric values. It means not any single value is not fixed for that. Okay? And the alphabets. For representing the variables, we are using alphabets and symbols. So alphabets and symbols which are used for fixed unknown quantity. Unknown quantity, it means that is not fixed. Okay? We can change that value. Just previous example. I explain you need total 3n matrix for making use. So in this n is what? This n is variable. Why? Because at the place of this n, we can use any. We can use various numeric values. Okay? And for representing these so many numeric values, we are using here alphabets. That is n. If you want 1, you are putting 1 here. If you want 2u, you are putting 2. If you want 15 u's, if you want to make 15 use by using math asterisks, in that situation you are putting here 15 and you are getting your answer. Total 45 math asterisks you are needed. Okay. Now see here at the alphabets you can use any, just like A, you can take B, you can take T, M, and yes, you have the 26 alphabets. You can use any one, but be careful, always we are using here small alphabetic letters. Let's see the next terms. Next term is algebraic terms. Algebraic terms. What are the algebraic terms? Here see, you have 4 algebraic terms: constant, variable, product of constant and variable, and product of variable and variable. These are the terms, just like in arithmetic, by using digits you are making numbers. Here we are making algebraic terms. How do we make? We need these 4 terms for making algebraic terms. Okay, algebraic expressions. We need 4 terms. See here, one is constant. Then this is already I explained you. Now, constant means fixed numeric value. You can write any number there. Variable, here we can use any simple alphabet just like X and etc. Product of constant and variable. Product. What is product? It means we need to multiply with this constant and this variable. This constant with variable. If we are multiplying this 2 with x, so we can write this is 2x. This 2x is algebraic term, product of constant and variable. Here constant and product both are multiplied. If we are multiplying 2 with 3, we are writing there, we write there 6. Because 2 3s are 6, this is fixed. Value is there and we have the value, so we can find the answer. But variable not a fixed value, no value is there. So this is always coming in this way, 2x. This is the final answer. Now next is product of variable and variable. Here we are multiplying 2 variables together. We can multiply 2 variables just like x multiplied with the y, you can write x and y. If a multiplied by b square, you can write ab square there. So this is what? This is product of variable and variable. Now again I am revising you. Algebraic terms are 4 algebraic terms we have in the algebra. One is constant, just like a fixed numeric value. You can think here any kind of number. Decimal, fractional, integers, whole number, natural number, any kind of number you can imagine here. Now variable, any 26 alphabets we have. So for unknown quantity we can let's assume any one alphabet. Now next is product of constant and variable. Product of constant and variable, it means we are multiplying the constant and variable, and product of variable and variable means we are multiplying here variable with variable. Okay. The next is algebraic expression. Algebraic expression. It is a combination. It's a combination of all algebraic terms. It means whatever we are studying here in these terms, the combination of these. Okay. So it is a combination of algebraic terms which is separated by plus or minus sign. Which is separated by plus or minus sign. Now you can see here just 2x I am taking from here. This is 2x, I am writing this. 2x plus x minus 2. Minus 2. So you can see here this is product of constant and variable, this is variable, and this is constant. Yes, here constant and variable, this is variable and this is constant. So it is what? Combination of 3 algebraic terms. Combination of these 3 algebraic terms, and these all terms are separated by plus and minus sign. See here, this is a plus sign and this is minus sign. So how many algebraic terms you have here? 3. 1, 2 and 3. Now let's see one more example. Just we are writing here x square plus 2x plus 1 upon 2. Okay. Now in this situation, again you can see here the first term. This is first term because each term is separated by plus or minus sign. So this is first term, this is second term, and this is third term. Okay. First term is product of variable and variable. And how it is a product of variable and variable? See, x square means what? X into x. Okay. Now, 2x is the product of variable, product of constant and variable, and it is a constant. So, again it is what? It is the combination of 3 algebraic terms which is separated by plus sign here. So algebraic expression is a combination of algebraic terms which is separated by plus or minus sign. The next is types of algebraic expression. On the basis of term, these algebraic expressions are 4 types. Algebraic expression are also known as polynomial. The algebraic expression is also known as polynomial. Poly means many. Okay, poly means many. These algebraic expression or polynomials on the basis of term. On the basis of terms. Recently we have studied constant, variable, product of constant and variable, product of variable and variable. So on the basis of these terms, there are 4 types. Now see here, first is monomial. First is monomial. Now monomial in which we have only one term. How much term we have there? Only we have one term. That algebraic expression is known as monomial. See the example, just we have only a, we have only minus 2, we have only x square, etc. These all are monomial because we have only one term. In this algebraic expression, we have only one term. Now binomial. In the binomial, we have 2 terms. How much terms we have here? 2 terms. Now see here, 2 terms we have. Example just like a square plus b square. How many terms we have? 1, 2. Terms are separated by plus or minus sign. So 1 and 2. How many terms? 2. X square minus z square. Again 2 terms. A plus 1. Again 2 terms. But look here. 3x. This is not binomial. This is not binomial. Why this is not binomial? It is a monomial. Now, this is the constant, this is variable. Why not 2 terms? But algebraic expression is separated by plus or minus sign. You can see here no plus minus sign. So it is monomial. It is an example of monomial, not a binomial. So these are the examples of binomial. In the monomial we have 1 term. In the binomial we have 2 terms. Now next one is trinomial. The algebraic expression in which we have 3 terms are known as trinomial. How much terms? 3 terms. Examples are just a square plus c minus 2. Okay. So how many terms? 1, 2, 3. Next you can take m plus n plus p. How many terms? 3. xy plus y minus 3. Okay, so this is 1, 2, 3. When we have 3 terms, that algebraic expression is known as trinomial. Next is quadrinomial. In the quadrinomial, we have 4 terms. How many terms we have? 4 terms. Now see examples. Just a square minus 2ab plus c minus 2. How many terms you have? 1, 2, 3, 4. So, on the basis of term, algebraic expression or polynomials are 4 types. When we have 1 term, known as monomial. When we have 2 terms, known as binomial. When we have 3 terms in the algebraic expression, that is known as trinomial. And when we have 4 terms in the algebraic expression, that is known as quadrinomial. Polynomial means what? Poly means many. Polynomial means the algebraic expression which have 2 or more terms. 2 or more terms. Now, what I am telling to you, 2 or more terms. It means here you have 2 terms, here you have more than 2 terms, So binomial, trinomial and quadrinomial. These all are also known as polynomial. These all 3 and more are known as polynomial. Next topic is factors of terms. Just in the chapter number 3, we have studied about the factors. Same we are doing here. But how do we find the factors of variable? We are not finding the factors of variable. We are writing the variables in the expanded form. Okay. Now see here. Factors of terms. Terms means algebraic terms. Are 2 types, constant factors and literal factors. Obviously we have the 2 types of terms there. One is a constant and one is variable. Remaining 2 are the based on the constant and variable. So mainly we have 2 terms, one is constant and one is variable. So factors are also 2 types, one is constant factor and one is literal factor. The factors of number, factors of numbers are known as constant factors. Okay. Now literal factors, the factors of variable. Factors of variable are known as literal factors because the variable is also known as literal number. Variable is also known as literal number. So the factors of variables are known as literal factors. Now see the example. Just I am writing here 36 AB square C. 36 AB square C. Now what are the factors of 36? See here. If you learn, okay. If you not learn, you can find it. 36 factors. You can write 36 as a 9 into 4. And 9 is 3 square and 4 is 2 square. But whenever you are writing power 2, that is known as square. And if you are writing power 3, that is known as cubed. This is known as square. And if you are writing power 3, this power is known as cubed. Okay. Now let's come back to the topic. I am writing here 36AB square C. Firstly, we are finding the factors of 36. Okay. Then we will find how we are finding the factors of variable literal factors. Now see. 36, when you have factorized this number just like you are done in the chapter number 3, same way. 9 into 4, 9 is 3 is to the power 2 and 4 is 2 is to the power 2. So factors are 2 is to the power 2 multiplied by 3 is to the power 2. These are the factors of 36. Now see here variables. How do we write these variables? We are writing in the expanded form. How? Just see. A as it is right. Then multiply. No sign between them. It means they all are multiplied with each other. So put multiply and b square. B is to the power 2 means b multiplied by b. So we can write here b into b and c is a single giant. So this is c. Everyone, now you can see here. These are the factors of constant number. And these are the factors of variables. These are the factors of variables. So these are known as literal factors and these are known as constant. So any can speak करेंगे. This is known. These are known as constant factor and these are known as literal factors. Why literal factor? Because variable are also known as literal numbers. Variable are also known as literal numbers. So factor of a fixed number, factor of a constant number is known as constant factor. And factors of variables are known as literal factors. And whenever you are writing power 2, you can speak squared. And if you are writing power 3, you can speak cubed. Let's see the next. That is coefficient. Coefficient means multiples of variable. Multiples of variable. Just I am writing 6x. 6x. So here you can see this 6 is multiple of the 6. Multiple of variable. Multiple of variable. If I am asking to you in this algebraic expression or in this algebraic term, what is the coefficient of x? What is the coefficient of x? So see here 6 into x. What is the multiple of this x? 6. So 6 is your answer. Just if I am writing minus 2xy. Okay. Minus 2xy. What is the coefficient of x and y? What is the coefficient of xy? So in this situation, what is your answer? Answer is minus 2 because minus 2 is a multiple here. Minus 2 play a role of multiple here. But if I am writing here minus, okay, if I am writing here minus 5ab square, okay, and I am asking you, what is the coefficient of a? Coefficient of a is equals to minus b. Coefficient of a is equals to minus 5b square. Why? See here. This a. This is a a. What are the multiples of this a? Minus 5 and b square. Both are multiplied. So, minus 5b square is the coefficient of a. Let's see some more example here. If 12ac square is given to you and the question is find the coefficient of a, coefficient of c, coefficient of c square and find the numeric coefficient. Find numeric coefficient. So in this situation, what are your answer? Yes, question is single. You have the single algebraic terms and fourth question is asking to you there. So coefficient of a. Coefficient means multiple of variables. So you can see here what are the multiples of this a. 12 and c square. So 12c square are the coefficient of A. Now next is, what is the coefficient of C? In this term you can see here, you can write this term just like a 12a c multiplied by c. This is c square, it means c multiplied by c. Now coefficient of c means multiple of c. So what are the multiple of this c? 12ac. And what are the multiples of c square? Because multiples are known as coefficient. The coefficient of c square is equals to the multiples of c square, that is 12a. c square's multiples are 12a. And the last is numeric coefficient. But in this situation, when question is asking about the numeric coefficient, we always write number. We always write constant, which is play the role of multiple here. You can see here in the 12ac square, which is a constant. 12 is a play the role of constant. So this is the numeric coefficient. So what is the numeric coefficient of 12ac square? That is 12. So this is about the coefficient and terms, factors of terms. Factors of terms are two types, constant factors and literal factors. Constant factors are factors of fixed numeric values, constant, and literal factors are the factors of variable, because variables are also known as literal numbers. Next, coefficients are multiple of variables. Let's begin the new topic, that is type of algebraic terms. Yes, we already studied the type of algebraic terms are four types, that is constant, variable, product of constant and variable, and product of variable and variable. But these four terms are further divided into two parts. Yes, these all four terms further divided into two parts on the basis of literal factors. On the basis of literal factors, it means on the basis of factors of variables. Variable के basis पे ये further two parts में divided हैं. One part is like terms and another part is known as unlike terms. Like terms. Which terms are known as like terms? The terms which are having same literal factor. The terms which are having same literal factor. Same literal factor, it means same kind of variables. Just A and A. Okay. Just I am giving one example to you. A square minus 2 upon 3 A square and 5.1 A square. These all are what? These all are having same literal factor. Here same kind of variables here. This is A square and A square. So these all terms are like terms. These all are like terms. But instead of that, if we have A, then minus 2 upon 3A square and 5.1 A square, these all are not like terms. Why? Because of A and A square both are not same literal factors. A factors means only A into 1. And A square means A to the power 2 means A multiplied by itself 2 times. Okay. So here we can say A and A square both are not same literal factors. Both are not having same literal factors. So here both are not like terms. Both are not like terms. So same literal factors, if any algebraic terms have, they all are like terms. And if the terms are having different literal factors, they are known as, yes, they all are known as unlike terms. Just like you can see here, these terms are known as unlike terms. Okay. Now one more example I am giving you. X square, 2xy and z. You can see here the variables are different, so these all are unlike terms.